Okay, so if you go back here, now we might be able to summarize this, make it a little bit cleaner. The next time we do this, instead of working this step by step like that, we could just say, okay, so they're going to give us a value of x. So this problem was 2, right? We can call it, let's say it's just a. This would be f of a plus h minus f of a over a plus h minus a. We go down and write that down below as a generalization. Okay. So the slope of tangent line at x equals a can be written as f of a plus h minus f of a all over a plus h minus a. Or the denominator could just be written as h. Okay, so this was with a limit applied, remember? Eventually, we had to put in a limit for that to get the true tangent, see? But this is something you definitely want to memorize. The slope of tangent line for a given point. Alright. So let's go ahead and use that the next time we were asked to find the slope at on a curve and they give us a value of x. Okay, speaking of which, let's go on and do an example. Okay, so I already wrote this one out here. It's y equals x over x plus 1. We're going to find the slope of the curve at x equals 1. We're going to find this equation of the tangent line at x equals 1. And we're going to find the equation of the normal line at x equals 1. Okay, so this is a fairly involved problem. But we do have a formula to take care of that first one there. Okay, so when they say x is 1 is our point of interest there, that is your a. Okay? Alright, so let's get started. So the slope is m equals f of a plus h minus f of a all over h, and limit applied in front as h goes to 0. So for this problem, the a is 1. So we're just going to do f of 1 plus h minus f of 1 all over h, and then we'll put that limit there. Okay, so this is going to be 1 plus h is what we're going to be using for x. Okay. 1 plus h. Whoa. 1 plus h. Okay, so it's going to look like this. 1 plus h over 1 plus h plus 1. Minus. Okay, and then we have f of a, which is just f of 1. So that's 1 over 2. And then there's an h there. Put the limit in. Okay, so we have basically the limit as h goes to 0 of 1 plus h over 2 plus h minus 1/2 all over h. Okay, so I want to multiply this top and bottom by 2. And I want to multiply this top and bottom by 2 plus h. Okay, this is 2 plus h minus 2 minus h. I'm distributing there. All over 2 times 2 plus h all over h. And if you remember Ms. Chen's little rule about ID on, we can basically just bring this h up to here. Just make it look a little bit simpler. Okay, so this basically cancels out. Oops. Oops. And so does this. Sorry, I made a mistake here. This is a 2h. There we go. But the 2's do cancel out. I'm sure you got that. Okay, so we do have a 2h minus h there. And this can be absorbed into this part. Okay, we have seen this again and again together. Studying. We keep seeing how this h cancels out. Okay, that gives us m equals the limit as h goes to 0 of 1 over 2 times 2 plus h. Plugging in 0, you get 1/4. Okay, so that's the slope of the tangent line. Let me extend the page here. Okay, that's part A. Part B, we're trying to, remember we're trying to find now the equation of the line. Okay, so the equation of the line looks like y minus y1 equals m times x minus x1. We're interested in the point 1 comma f of 1. This is our x1, our y1. Okay, so we should probably figure out what that is. Okay, so let's just go back here. A was 1 on this problem. F of A, we never even figured it out, did we? It's 1/2. Okay. This is your x1 and your y1. So it's going to be y minus 1/2 equals m, that's from earlier, times x minus x1. You can leave it like that if you like. I believe on the AP test, if you're doing a free response, you're allowed to leave it in this form. But it is nice to have the y equals mx plus b also. So we'll just go ahead and write this in. Yeah, I believe that this is the correct answer if you isolate y. Because that's negative 1/4 and you're adding a half. So it's positive 1/4. Okay, so what's this whole normal line business? Okay. Okay, so why don't we, take a look at that graph here. Okay, so I just brought in the graph. I gotta shrink this, sorry. This is the graph of x over x plus 1. Okay, we were interested in the point 1 comma 1/2, which is about right here. And we just discovered this line here. One fourth x plus 1/4. So I tried to make it have a 1/4 slope. And tried to make it pass through 1/4 here on the y-axis. Okay? Alright, so there's our equation of that line. And it is perfectly tangent to this point. It touches exactly once, which is cool. So that's what we accomplished in parts A and B. Okay, for part C, what they'd like us to do is to find the equation of the line that is normal to this line. Okay, now this is called tangent, and I guess I probably should have mentioned this, but this is a tangent line to the point 1 comma 1/2. It's not referring to the same tangent as the trig or the trig function. We're just talking about a line that touches once locally. Okay, so normal line is a line that's perpendicular to that one. That. Okay, so normalcy is literally means perpendicular. The normal line is perpendicular to the tangent line. So most people who are looking for a normal line first find the tangent line. Okay, this makes it really easy to find because you could just use y minus y1 equals, and then use opposite reciprocal slope. So for us that would be negative 4 over 1 times x minus x1. And I got the negative 4 over 1 because it was the opposite of the 1/4 slope. Should have a negative 4 slope. Okay, and then we got to put in the x1 and y1. So what's x1 and y1? Well, it's a point that's on the line. And we're still passing through this point, 1 comma 1/2. So we're just going to put those numbers in. Okay, so it came out to be y equals negative 4x plus 9/2. And that's because this over here distributes to make a positive 4, and you're adding a half over. So that's 9/2. And that's the equation of the normal line. Y is equal to negative 4x plus 9/2. And that'd be the answer for part C. There's another line on this graph that has the same slope as this black line. It's actually over here. We just need to find out where it touches. Okay.